welcome to new episode of Making Diablo Clone in Lisp. So today we are going to continue where we stopped last time. So we are going to work a bit more on this actions refactoring for the ones who hop in just now. I've been doing this large refactoring in the game in which I've kinda made the different mechanics like moving or picking up an item or attacking other character in close combat. I've been making those in the similar mechanic which I called actions. So by now I'm pretty fine with within API, I guess. So the only thing that is left to commit this code is to optimize it a bit and of course to document it. So today I'm going to do the former, and we'll do some premature optimization. So today I am going to be looking a lot at some disassembly and trying to make it better. So that is going to be fun. Okay, so the first thing that I want to do is I think I want to switch to turn on globally the high optimization settings and just have a look at those. So and I also have this to do to make those levels changeable, but that's kind of trivial, but I will make it later. So I want to have debug at 0, compilation speed at 0, then safety at 0, space at 0, and speed at 3. So that's the highest optimization settings. I think I want to change the order a bit. So I'm going to start with speed and then safety, just to have it in some logical order, and then debug. Speed, space, let's space in front. Here we go. So now I think I want to remove my cache with possibles. Lisp as BCL, that one. Prompt in dev. That one. Oops. Right, and now I want to restart my Lisp and quick load that stuff again. Also, I think I want to quick load it with looking at the verbose ASDF output. So how do I do that? ASDF, something like verbose, not that. That's from work. Right, how do I do something like QL quick load, like the usual, but with some keyword arguments, I think. Let's just quickly Google for that. So I want to have ASDF, and I want to have quick list, and I want it to be verbose. Okay, data verbose. Was in the main page. Okay, we got most blah blah blah. You can show the full compilation on output by passing verbose t with the arguments to quick load. Nice. So we want to quick load the to clone kit, and we want it to be verbose t. I think I want to pull in my REPL, and here we go. So I just wanted to have a look at the warnings that are happening, and indeed they are happening in quite a big quantity, I would say. Perhaps I want to... that's a lot of them. It's not... okay. Right, maybe I want to set speed to maybe 2. And then there would be not that much of a warnings. Okay, I think I will look at warnings later. So now I just want to optimize that actions stuff. Okay, so where do I start? I think by this moment I can delete all of those comments with the previous versions and sort of to-dos, etc. Yeah, right. Okay, and then I want to start optimizing by I think looking at the functions that are called most, and I guess those would be, yeah, and I want to rename some things, but yeah, I will do that later. By the way, I don't need this debug output, I think, by now. Do I? So if I, when I can start the game and just see what those debug outputs are. Man, that's a lot of compilation warnings. I think those are going from the UI, which is compiled on the fly from, well, my UI DSL. So yeah, here we go. Swinging, moving, tracking, swinging. Sorry. So yeah, I guess it all kind of works. And I don't really. Oh, yeah. But that's to be expected. This spider ant is stuck on that stone thing or whatever because it is the obstacle. And well, I still got movement code not perfected. So if I move here, he will, yeah, follow me. Oh, I think I've heard this bug with multiple attacks. I think. When some, yeah. But again, I guess this is related to how movement happens, and I will work on that shortly. I mean, in the closest couple of weeks. So yeah, anyway. So I wanted to delete all of those debug things, because I don't really need those. And also this one, yeah, that's also purely debugging thing. So that's that. Executor. Parent child stuff. I think I can even remove that helper. That's just some function that calls another functions. So yeah, I also don't think I need this. Different actions. Oh. Ability for system to process several different actions, but that's actually possible with current API. So yeah, here we go. Execute actions. Yeah, I think I want to remove that extra layer of wrapping. So this is process actions. Yeah, there we go. Oh yeah, but that's just called like this, process events, like in the same manner. So maybe I won't just rename this one. Oops. Yeah, here we go. Oh. Alright, so does this still work? Oh man, these loading times are killing me. Right, yeah, this still works. Alrighty. So, where was I? Yeah, I think I want to start by optimizing the functions that are called most, and I think the first candidate for optimization would be the so-called constructor for an action. which is like make whatever action. So it should be somewhere here. Yeah, this one. Make and struct is the struct name. So let's, for example, have a look at the disassembly of. Come on, disassemble. God damn it! Why slice completion is so weird? Yeah, right, disassemble. So I want to look at some constructor, for instance. Let's have a look at make. I don't know. Movement action. Yeah, make move action. That one. Alright, so I can already see it does some memory allocation, which is not very good. Because, I mean, these constructors might be called quite often, actually. So, let's dig in. Oh, that's a big one. Yeah, okay. Make move action. So this is the result of macro expansion of this thing. Right, so let's see. What do I have here? So we got those global variables current action. Is it like using that library? Let me have a look. Current action. Where the heck it is? Like with this star. Yeah, here we go. Oh, it is some sort of wait a sec. So global vector ref. Its first argument is index. Oh, so that's just an integer then. Right, but why? Where it is defined? Entities. Oh, okay. Current action. Oh, that's actually a global vector, but anyway. Right, yeah. Okay. So we reference that in the. I mean, why it is the global vector though? Oh, I guess for every entity there is different set of actions. Yeah, of course. Okay. So we reference that. Then we already have generic equals, which we shouldn't. Yeah, and that's because of that equals, I guess. So why the heck this happens? Parent, index. And I don't even have the type declaration for that. Oh, yeah, I see why that happens. Yeah. Yeah, of course. Okay, let's have a little type declaration here. So it shouldn't be inline, but we want to declare a type. So this is a function taking an entity which is num, and then taking keyword arguments. I'm always forgetting how to specify a type for the keyword arguments. Yeah, type. Function. Yeah, but how? Functions. Yeah, that does not happen very good. Okay. I think I want to look CLHS for function. Here. No, not that. That one? Nope. That. No, that's just a type. Oh yeah, here we go. Key initial T. Oh. Okay, so I should specify obviously the name with the keyword and then the type, right? Yeah, this is some awkward syntax right here. Okay, let's try. So we have parent, which is again a fixed num, Oh, and we have, oh right, we have a lot of functions here, so I mean the arguments, the keyword arguments. So we want to make, we want to macro generate this. So this will be the list, and again mapcar, and then yeah, I guess list would do probably, and then slot names. So what are slot names? We take, yeah, those are symbols. This wouldn't do. I need a lambda here. Come on. And, so it would take slot name and then type. And then just have a list. Oh yeah, T. Type. And then it would be the list of keyword. I reckon there was some helper in Alexandria, like make keyword. Yeah, that one. So we would work with symbols. Yeah. Make keyword from the name and then have a type. So that's it. And then, man, that's already quite a long string. So let's maybe have, nope. How do I make it better? Type function here. Maybe just have stairs like that. Type function, and then this one, and then that one. Yep. So we want to mapcar that lambda to slot names and obviously slot types. Do we have those slot types? Anyone? Wait a sec. So I'm not seeing slot types here. That might be a problem. So how do I call defection anyway? So let's have a look at the character system. Right, I do have a type here actually. But I think probably I'm not getting that information out. Do I? That slaves lots. Yeah, I'm just not extracting that. But that is here. Okay, so let's just extract it then. So yeah, okay. So slot types would be. I reckon I already did that somewhere, so I will just reuse some code. I think in components. So this should be get f something. Yeah, like this, just like this. So in mapcar get f as okay, what is oh, the default. Yeah, okay. So then slots, and yeah, that's that. That's our types. So slot names and slot types. Here we go. So this is our type declaration, and now we want to apply this declaration to our function, to our constructor function here. So here we go. So I guess that's that, right? Okay, compiled and loaded. So let's try and compile again the defection here in character system. Yeah, no warnings. And let's have a look again at make move action. Oh man, that's a big function. Okay, so yay, now we don't have generic equals. That's a little win. So where was I? Yeah, I've been here. Can I maybe make that a bit nicer? Just a tiny bit. Like that. Yeah. And maybe one step further. Nope, too long. Alright. Yeah, that would do. That certainly would do. Okay, so what is happening here in this assembly now? After having checked with current action, we jump to label 39 where we delete entity actions, I guess. Let's have a look at that. Yeah, we call that function and we jump again back to label 3. Let's go back to label 3. Alright, label 3. So, move actions. Then we reference move actions, we reference move action deleted indices, we do some comparison and we jump to label 33, sorry, 32. So let's have a look at 32. So that again references move action deleted indices. And I mean, this is weird that these numbers get different every time. I guess it's kind of a bug in SBCL, or not a bug, but well, not a very thorough optimization. But yeah, anyway, perhaps I would report it at some moment. Let's have a look again at this. Oops. Okay. Action deleted indices. Yeah, so there are different like offsets every time, despite this being the very same variable. So yeah, that's weird. Give me a moment. I think I want to lower a bit. Yeah. Right. So delete entity actions. We call that. Then we get back to label 3. Then we are doing deleted indices. Yes, we're trying to get an index from deleted indices. So we're checking it with 0, and then we kind of allocate maybe from the deleted indices. Then we have move actions. And we have action deleted indices, and then again the same story. We are trying to allocate a new index that's been used before here. Yeah, we jump to label 25. Let's have a look. Why this is not working? Oh, it works differently. Yeah, okay. So what was that? Label 25, I guess. So I can go with VI bindings, yeah, like that. Okay. So action deleted indices. So what is really happening here? Action deleted indices. I think we are getting an index from there. Yeah, it very much looks like that. Oh, 5. Yeah, okay, let's go back. Right, so now we are working with actions. That one. Okay, so what are we doing here? Yeah, and we are getting it every time from a new... Oh, wait, I think perhaps it is the same variable. I mean, it is the same object, but here we have the offset, the instruction offset, like 586, and because of that we have this offset. And for instance, here to reference that, we have different RIP, I mean different instruction pointer. And that's why the offset here is different, but it still references the same object, I guess. That's clever, and that's not actually a bug in SBCL then. Okay, alright, one mystery solved at least. So what is happening here is a lot of set Fs to those different things in actions SOA. So that's that. We can't really do much more about that. Wait, there are some jumps for some reason here. Let's have a look. Oh yeah, that's the growing procedure. And have a look. 1.3, 1.4, yeah, they are different. Even though those are actually kinda the same, but yeah, optimizer does not bother and just put the bodies of those inline functions inside this function, despite they are the same. That's not very clever. Oops, I've spilled some tea. Okay, right, so can I do something about that? I guess I can't do much because there are different like accessor functions. They're inline and they, I think they're even have, oh, okay. Yeah, right, so I can't do that much about that. So okay, those are those different set f's. So what is happening after that? Then we have move being set here, I guess. Reference actions again for some reason. Maybe for that instruction, which again, yeah, works with parent. Then current action. We are. Why are referencing? Oh yeah, here that's the last form in set f. So we set f the current action to be this new action being created. Okay. Then reference actions again. I think for that form. Yeah, we put move there, and then we call initialize action. Oh yeah, move is for that. So we call initialize action, right, which is kind of custom initializer for this constructor, and then we return. That's the end. And here are just the blocks for those inlined functions. Right. Which are actually the same, but yeah, okay, anyway. Oh, I've been watching at different, I mean, at not very right function. Oops. But still, they are very much the same. So, same things happen here. We reference actions several times, and reference current action, set move, call initialize action, that's that. And here we again have the bodies of all of those inline functions. Yeah, right. So this, maybe I can work this around and this function would not be that big if I would actually have this growable vector growing function not inlined. So because of that, there would be just a function call. Can I make this trick? So okay, let me have one more look. So, oh yeah, and there's also the mystery of sudden memory allocation. Why that is happening? Okay, so that's big. So okay, 2 and 6 kilobytes. So why should I start? Okay, I will look first of all at this allocation. Why is this happening? Oh, alright, so we allocated right from the start for some reason. And I'm not very sure why. Why would you allocate memory? And this looks like the just one cons allocation, but I'm not very sure if that allocates just one cons. Okay, let me just have a look. Cons are and something we know as b4. So why this is called at the very start of the function? Why do we need that? Okay, let's have a look at the function. Cons to R and N. So it ends here, it's not that big. We call initialize action, then return global index here. So this is not aligned, I presume. Is it? What? I think it's also defined. Oh yeah, here. So yeah, this is not aligned, and well, what the heck? Right. Wait a sec. How do I process those things here? I mean, I'm not. Oh, yeah, here I'm using. I'm initializing the fields here. Yeah, okay. This also does not look like it is allocation needed. Although this thing looks suspicious because of that. I mean, this is always the same list. Yeah, maybe if I replace that with an honest to God list, it could work. Yes, I think that's what I meant here. Alright, so let's compile that again and have one more look. Right, so nope, still here. So we still have an allocation. God damn it. So why? Okay, let's try and analyze this prologue of the function. So first of all, we test some parameters and we jump to label 40. What's label 40 for? Right, so we move something and jump back to label 2. Let's have a look at that. Oh, wait a sec. So this allocation, I guess it is kind of requesting 17 something, 17 bytes or 17 cons, and that's awfully weird number. Why 17? What is the magic here? I mean, I'm not even sure. 17. That's weird. So I don't have any more suspicious macro expansions here. And again, 17 bytes. What is happening here? Right. So we test some things. We jump back to label 2 here, and if this label 2 is skipped, if like we go this branch, if this if this comparison is true, then we fiddle with this pseudo-atomic bits. What the heck? Follow region, and then we jump again to 41, and that's where we do our allocation. Okay. Travel region. So I guess result is in R11. Region x minus 39. And then orbit 15. Blah blah blah. T and what? What T? And then we jump to label 1 here. And if not, we okay, dependent interrupt trap, which I'm not even sure what it does. Okay, so that is quite weird. Maybe if I can track where this memory is used, then I kind of can understand why it is allocated. So yeah, let's have a look. 17. So, well, first of all, I want to Google this const to RNN thing. How it does even operate. Nope. Nope. Well, Google is plain dumb. Alright. Compile. Right. Maybe I even have to look in SBCL code. Goes to RNN. Oh, it's here in SBVM. Okay, I can actually go to that, or well, at least do something. Right. No definition. Okay, I will just look at the assembly. I will be good with that. Oh, alrighty. How does that happen? Goes to RNN. Here we go. Oh, maybe that's not a function, but something like SBCL intrinsic or whatever. Alright, so no luck here. Okay, so let's get back here. So the result of that should be in some register, I guess. So, okay, let's get back to the beginning here. So we return here. Okay, when we return here, we jump to label 0. Oh, pop RIX. Why we pop? Okay, we push 17 and then is this the optimization or is 17 the argument for this const to RNN? Man, that's hard. Okay, let's get back to label 0. So yeah, it looks like RIX is the result of allocation. So we put -39 to this memory, to the beginning of the memory. And then we do something weird with that address and jump to label 1. Okay, so this looks like some manipulations with argument list. Maybe this has something to do with the fact that those are keyword arguments. So entities, yeah, weird. That's weird. Maybe it is even some way to trace SBCL compilation. Okay, I will have to search for that. This thought haven't occurred to me before. I will just write it down. So compilation tracing, compilation tracing. All right. I will try and Google something about that. But yeah, anyway, so there's not much to do here for me, I guess. Yeah, except this thing with those inline function, which is the same and yet its body is over and over here in this function. So maybe I can make this one a bit shorter, but by making that not inline. Okay, so how does that work? So this so this somehow calls, I'm pretty sure, global vector ref with setf here, and this calls, what does it call? It should call grow somewhere. Oh yeah, with no bounce checking. So it calls this one with a star, and this thing. This thing calls grow. Yeah, here we go. So grow defined as inline. So perhaps by defining this not inline, I can. Yeah. First of all, how does that even work? I'm not entirely sure. I remember. Okay, line not inline. So line specifies that it is desirable for the compiler to produce inline calls. Functions named by function names. Okay, so what's the deal with not inline? Not inline specifies that it is undesirable to compile the functions named by function names inline. The compiler is not free to ignore this declaration. Calls to the specific functions must be implemented as out-of-line subroutine calls. That's what I'm looking for. So I guess I can try and do that. There's the trick, because there is like one level of indirection. I'm calling some function which is inline, which calls growable vector grow, which is inline, which calls setf growable vector f with a star, which is inline, which calls growable vector grow, which again is inline, and I want it to be not inline. Okay, let's just try that. Let's just try and declare here at the very beginning that not inline growable vector grow. I reckon I've been trying that before, and I'm not sure I remember the result. Okay, so that's not inline. Alright, so let's compile again some action, like this movement action. One style warning, what that might be. The claim where declare was probably intended. Probably it was. Yeah, sorry, I always mix those two. Declare. Okay, no warnings. So, well, let's have a look at the disassembly for that. So frankly, I can't see any external calls, and yeah, still 2 and 6 kilobytes. So I guess, yeah, this does not help very well. Okay, so this means that this trick does not work when I have inline function call some other inline function, and then I all of a sudden can't control the, so to speak, alignment of those another function. Yeah, this kind of makes sense. Okay, so where was I? Oh yeah, I want to delete that too, that debug crap. Yes. Alrighty. Oh, and I want to debug this debug crap too. So this is just one, yeah. Yeah, some sudden cleanup. Okay. So yeah. Yeah, so I guess I'm doomed to have these large functions like this one. But again, it does nothing, almost nothing, except some moving back and forth. So okay, that's my constructor, and it looks kind of okay, despite this memory allocation, which I have no idea why it happens. Okay, I think I will leave a comment here. Allocation here, like weird 17 bytes. Right. Okay, so now maybe I want to look at functions that are called from this one, like this delete entity actions. So let's clean REPL, And yeah, let's have a look. Oh, that's nice. That's nice and short. So what it does, let's have a look at its source. So what it does some loop where it goes through current action for an entity and then just deletes it. So yeah, let's see. Example 1, that's the body of the loop, I guess. So we compare some stuff and jump to level 0. And then yeah, L2 is the end of the loop. Now we return nil. Okay. And then here. And there's nil for 2 times here, which is weird. X, action. So we move nil to EAX and then we move something to RAX, which seems weird. Why this first one, if it will be, well, replaced in this instruction? Weird. Yeah, that's weird. Okay, so what happens here is, yeah, well, honest to God loop, where we just subtract some stuff, call delete action, and yeah, reference actions, and blah blah blah. Yeah, it's this all is good. So let's have a look at delete action maybe. Where is, yeah, here it is. Yeah, maybe I would want to optimize something here. So yeah, anyway, let's have a look. Ooh. Okay, so it's this is a bit bigger. Right, so we call do delete action, which is generic. Oh yeah, okay. So I think for this one, oh yeah, no, I can't use any close accelerator here. I mean, those libraries that replace generic calls with specialized versions of compile time. I can't because these can be specialized on any type. Yeah. Okay. So we call this generic, the delete action. And I mean, that's weird name. Am I even... Oh yeah, I think I'm using it here in this macro. Am I? Let's have a look. Where was that? Do delete action. Yeah, I am using it here. Alright then. Okay. So I'm calling this generic, which is not very nice, but still, what can I do? So then we go grab after push. So we add these indices to the list of delete indices. So what we do afterwards? Some movement, and then jump to level 6, which is, oh yeah, the growing of the vector, this one. Okay, so then we get back to here, and then we reference actions again. Yeah, here I think we put deleted there, and now we reference it several times here. Yeah, okay. And then I guess we have all of those values, entity, parent, and child. Do we kind of need all of those? Yeah, we need all of those. So then we do some stuff with them, right? Wait a sec. Where do we put in those values? R6, R9. Oh yes, so the first time it looks like it's... No, wait a sec. RAX, and then we use an RAX again, but then here RCX, and then weird. Yeah, okay. Let's move on. Oh, there is some function called here which is not labeled, which is like super weird. And then we jump to level 5. Weird. That's kind of weird. But okay, let's move on. So where were we? Here. So we got all of those things. Then we jump to L1. Then for some reason conditionally jump to L5, and here at L2 I guess we are doing all this stuff with... Oh, wait a sec. I don't see the call of delete action here. Oh yeah, it's the recursive call also. Maybe I can make that tail call and optimize this a bit. But I'm afraid this might break the subtle logic here. Oh yeah, and I think it will. It will break some subtle logic because delete action would access some values that we are modifying here. So yeah, I can't make that tail call. Okay, let's just have a try. Let's just try and put that to here and see if that still works. Wait, what? Define variable child. Oh yeah, I think extra parentheses. Yeah, here. Okay. Right. So let's try and launch the demo, and I'm almost sure it will break in some way or another. Come on, just launch already. That's what I've expected. Yep. Okay. Yeah, just quit it already. Oh, god damn it. I guess I will just restart my Lisp. Alright. So I would take that back as it was. And then just quick load delete long kit again. So will it work now? I mean, it should. Yeah, all good now. Oops, I guess I'm dead. Yep. Okay. Where was I? So let's have a look again at this delete action. So yeah, it kind of looks big, but well, 600 bytes. What do you expect? So I guess this all is still fine. So what am I calling from here? I guess I'm not calling anything really from here. Let's see. Yes, we call do delete action, which is generic, and then some weird function called here, and then adjust array. Yeah, okay, all good. Yes, right. Okay, so let's get back here. I think this comment is not quite true already. A possible leak when parent is not equal to any of this current action. What is parent? Yeah, I guess the parent here will always be in this current action. Because when I'm creating some, it replaces current action, and then yeah, I guess there could not be a loop here. Okay, that's questionable. I will think about that maybe later, or maybe we'll leave that comment here. Well, yeah, okay. So I guess I have to have a look to some other things here. Right, so for instance in character system, make components, yeah, I want to look for some using of those entities mechanism here. I have initialize action and I have an executor. Yeah, I wanted to test some stuff here. Yeah, alright. So I recall quite vividly that there was some room for optimization here. So we just looked at make move action and it looked alright. And we also looked at delete action, which is kinda fine too. Delete action. Action print. Am I even using this anywhere? Yeah, I guess I'm not, but I will just leave it for the debug purposes. Yeah, I guess I want to look at how that works. Nope, run away, give me some time. Okay, so action, goddammit, action print 0. Yay. Action print 1, oops, nope, no. 1, and that's 2, and that's 3. Okay, so this all is good, I guess. So action here, so I think I just want to clearly indicate which index is global and which is local. So let me just do that. So which one is okay? String action. So this one is global. This one is local. Okay. So global. Oh. That's a lot of stuff to process. Right. Okay. So where was I? Let's maybe now have a look at some other functions. Yeah, I guess what I want to do is just to quickly compile all of those and see if any warnings pop up. So I guess there are no warnings here. And even here. So I'm only interested in functions. Okay, so I'm not seeing any warnings, so that's a good sign. Yeah, except this action print thing, which prints a whole lot of those. Okay, and I will optimize due to uncertainty. The first argument is full stream, not a stream. Oh, okay, that's easily fixable. Oh, yeah, that's not very easily fixable because it can be nil or stream, and that's yeah, right. It can be nil or it can be even t, so it could be really anything. Would that help if I'll write something very dumb like that? The stream. Oh, it can be nil, so it would not work. Wait a sec, would that work? The nil. It works, but that's incredibly stupid. Okay, stream. Yeah, okay, so that's not, the type of stream is not known at compile time. That's what compiler tries to tell me, and I mean that's not news. Although the first argument is or boolean stream vector character. No, it actually could only be either boolean or a stream, nothing else. So yeah, wait a second. So what? First of all, what is the type? How do I type of? Yeah, type of, for instance, standard output. No, output. So it is. Yeah, I guess a stream. Do we have that type? Stream CL. Yeah, we do. Stream. So I guess the type declaration would suffice here. So type function is none, and optional. Here it is either boolean or. Wait a sec. Let's go to the definition of format. Is there even a definition for that? Oh yeah, there are different optimizations here in this DCL for that. So there is specializations for nil, specialization for a trueish thing, a specialization for stream, and for true. Yeah, I guess I will just leave it like that, or boolean or a stream. And that's the declaration of action brings. I'll let them compiles. Alright, still a lot of warnings. So let's go back. Due to type uncertainty, first argument is or stream boolean, not a stream, not a member t, not a null, not a stream, not a member t. Yeah, so the compiler tries to replace the format call with some fancy precompiled thing, but we won't let him because, well, we don't know on compile time which the type of stream would be. I guess I could go with the same trickery as the format, but yeah, that's the extra length for some dumb thing as the debug printing. So I will leave it be like that. Right. So let's try and compile some more stuff. So warnings. No warnings here. So this is a macro and still no warnings. Now this one. No warnings. No warnings and no warnings. Awesome. Right. So let's get back to the macro. Let's get back to functions which this macro defines at macro expansion time and try and optimize some of those, or at least look at how they, to what they compile to. Okay, I think I need some sugary stuff. Right. So we are defining here the length helper. How do I even make a name for that? Okay, so let's disassemble that. Let's struct as such, so that would be move actions length. Fine, yeah. Alright, that's super short and super nice. Is it in line though? Yeah, it is. So nothing to do here, really. Wait, oh yeah, here. Alrighty then. So let's go further. So we just looked at the constructor here, make whatever struct. Sorry. So let's have a look at the next one. Okay, so the next one is the macro again. And the next one is a macro. Okay, so now I have a generic method. Right, and some another method, finalize action type. So this is called only once, if I recall correctly. Yeah, at finalize actions. And this one is called several times, but yeah, I reckon there was some room to optimize by using some close accelerator libraries, like here. Right, so initialize action. Where it is called? Right, it is called here. Okay, so we can optimize a bit further by using one of those libraries, and then this generic call would translate to just a regular function call, which is nice. Okay, so let's have a look at the list of those libraries. I had that somewhere in my private bug tracker. So somewhere in this catch call issue I had some links. Yeah, so there are inline generic functions library. It is static dispatch by some guy. And there's fast generic functions and something that is specialization store, which is, I'm not sure it's from this domain. So let's have a look maybe at this first one. The speed of static dispatch to close. Okay. So we're gonna generic function with inline generic function meta class. Meta class is subclass of blah blah blah, therefore blah 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 blah. It acts exactly the same. Alright. Then define methods as usual, define a function which uses it. At this point the generic function is not inlined. Yeah, I guess so. Now it's the time to inline the generic function. Here there is nothing different from inline than a normal function. In order to inline the generic function, just declare an inline when you use it. Oh, I guess it does the full inline, so it will replace this initialize action call with the full function. I mean, with the whole body. I mean, it's not even that bad, I guess. So let me have a look, for instance, at some examples. Okay, so we have this initialize action for a tracking action and even more for a movement action. So do I want this to be inlined? I guess not, because this function is quite big already. It's like 2.6 kilobytes. And if I make it even bigger, it wouldn't even fit in a single page, and well, that's not very nice. So let's maybe have a look at other alternatives. static dispatch, and fast generic functions. So let's have a look first at this one. What does it? Right. Is it just my... yeah, the dark theme is quite lame. Right. This library introduces fast generic functions, that is, functions that behave just like regular generic functions, except that they can be what? They can be sealed in certain domains. If the compiler can then statically detect that the arguments to the fast generic function fall within such a domain, it will perform a variety of optimizations. That sounds just like what I need. Okay, example 1. The first step is to define generic function, classes, fast generic function. Okay. Once the definition is loaded, and only then, so we shouldn't put the next snippets in the same file in the generic form. Wait, what? Once this definition is loaded, it is possible to add methods to it in a usual way. Okay, that's the weird comment, but okay. As a novelty, we need to calls to seal the main. So it needs some extra calls here. Optimized by the variety of ways. By default, the call to the fast generic function discriminating function will be replaced by a direct call to a custom effective method function. Yep, that's what I need. This means that there will be zero overhead for determining the generic function's behavior. Functions and illustrates. Example 2, sensible generic functions. It is even possible to inline the entire effective method into the call side. However, to avoid football, this feature is disabled by default. Enable the feature name must contain the proper declaration as shown in the next example. Each method within a sealed domain must contain an appropriate declaration. Oh yeah, inlineable, this one, I guess. This is to generate such a binary function to a function that accepts a number of arguments. Define the method. Well, that's some trick right here. Specializing using defined class. Okay, this seems this looks good, but you need to make this extra calls. I don't like it very much. Let's have a look at this last one, static dispatch. Inspired by a generic function, which allows generic function dispatch to be performed statically at compile time rather than dynamically. This is similar, blah 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 blah. Okay, how it works? This time, yeah, okay. Stores the body of the method in a global variable which contains a hash table mapping generic functions to their methods. Oh yeah, that's the default behavior. No wait, that's the shadow def method macro. A compiler macro function is added to the generic function which determines the types of the arguments and replaces the function call form with the body of the most specific applicable method. If the types cannot be determined, there is no more information, we will call as is. Thus, in order to choose the appropriate method to compile them in time, the types of the arguments either have to be declared using declare or surrounded in a that form. Okay. Usage. Again, I would have to import this package instead of common LISP, which is weird, but okay. And then to closer mob to function correctly. I mean, do I even need closer mob? Range. Okay. Currently, the following are supported: Ladder or Radar, C-LISP, Closure, C-Root, embeddable, still blank. Okay. We will support it in the past. Alrighty. Generic functions and methods as defined as usual. Using generic and def method, generic functions are dispatched dynamically and are identical to standard common generic function until the following declaration is in place. Line generic function name. In order for the appropriate method to be chosen, the right hand blah 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 component form. Variables have type declaration functions for users. Type, data forms, constructors. Yeah, that's all. Just the regular type inference that's to be expected. Both equivalent class providers are supported. Equivalent methods will be chosen statically. The argument is one of the following and is equal to constant variable, constant variable, constant variable with a type equal declaration, macro symbol. Alright. Next method P are supported fully. Blah blah blah. In order to type on the declaration to be made available, the compiler macro constantly should be enabled hook function has to be called at some point. So some extra function call again. Implementations where the code blocker is not required, now we can disable hook nothing. So is there some examples? Oh yeah, okay, differences from inline generic function. Uses a custom generic function meta class which stores the method's body. Oh yeah, that's that library. Whilst this approach is more robust than shadow and def method in order to store the method blah blah blah. As it will be able to inline methods added by other means. The meta class has changed from the standard generic function meta class, which implements several optimizations of the dynamic generic function dispatch from being performed by the compiler. The result is slower execution speed as shown in here. Oh, alright. Static dispatch does not use a custom generic function meta class, thus generic functions are identical to standard common Lisp generic functions, and hence the usual accommodations are performed unless an inline operation is in place. Okay, that's a lot to read. Where are examples? There are no examples, okay. Does not support user-defined method combinations before, after, around methods. I guess I don't have those right now here. Yeah, I don't. Okay. Test upon CCL, BCL. Nah. Okay. Right, so let's have a quick look. So all of those look kind of supported, well, just if you close eyes to that. So yeah, inline generic function is not what I actually want to do. I don't want to inline the whole body, I just want to well, omit that overhead caused by having the runtime dispatch. So I just want static dispatch. So this looks nice, but it needs some extra functions, some extra calls. Yeah. Seal the main. Yeah, right. Seal the main levels. Okay, so let's try that one. Fast generic functions. let's just have it on the fly without without any commitment. So I mean without adding those to ASD file. Let's just quick load files generic functions. Let's try and use that. So let me just quickly disassemble again. Come So make move action, for instance. At some point, this calls this thing. Wait a sec. Yeah, this calls transaction. So yeah, here it should be somewhere here. Wait a sec, where is that? I can't see. Yeah, here, initialize action. And if I disassemble this, it would be actually the stub to do runtime dispatch. Yeah, that's that. And it does a whole lot of stuff on memory allocations. So, at that point, when calling this like make move action, for instance, I already know which effective method I would need to call. So this is the room for optimization. Okay, so let's try and have it. Try and use it. Once this definition is loaded, we're done, so you shouldn't put the next snippets in the same file. This bugs me. I shouldn't put the next snippets in the same file as dev generic form. Weird. And yeah, what would be the sense? Okay, that's really weird. And does this one have this library does not seem to have this limit. Okay, so anyway, I will maybe try and put that. Oh, I don't even have the def methods here. I have them in corresponding files, so I guess that's fine. Okay, yeah, right. So how do I do that? Function class. Does this library have an alias instead of using this full thing? Sorry about white background. No, it does not. It does not have a nickname. Okay. So let's go with that. So, initialize action. Well, I still do have one specialization. Okay, let's just go and try it. Oops. Not change class objects into generic function meta objects. Whoa. Okay. I guess I would have to reload it then. Okay, once the definition is loaded, it is possible to add the methods to it in the usual way. Just in the usual way. Okay. The novelty of the calls to seal domain. These calls seal the specific part of the function domain and at the same time install file. Okay, first of all, I should somehow put this specialization somewhere else for this generic, fast generic function stuff to work. Where do I put that? Initialize action. don't even have any nice idea about that. Maybe I should put that. Okay, let me just copy that and put it somewhere where it would be picked up later. For instance, in, I don't know, entities. So okay, does my entities file depend on actions? Oh, it does not. Okay, but does actions depend on entities? Oh, but they do. Okay. Okay, alright. So okay, I need something that depends on actions, but not a regular system. Oh, there is not much of those. Okay. And it shouldn't be entities or components or systems. God damn it. Okay. I should put it somewhere else. Okay, anyway, I will leave it be for now. I want to just have a look at how that will work. Right. Fill domain. So I guess I want to call that somewhere here. Oh yeah, I think I want to. Right. I want to call that, for instance, here, and I guess I would need to have some sort of macro that will define the initializer. But anyway. So first generic, come on, the functions, seal domain of how do we call that, of initialize action. Come on, action, and be. Oh, but would it work with equal specializers? Oh, I'm not even sure it would. Specializing on user defined class. Right, let's just try. So it would be something like equal track and t, something like that, I guess. Does not take okay, so I guess I need to restart, but first of all I need to add it into ASD file. So for generic functions it is. Okay, let's try that. Wait, what? Okay, so while compiling actions.list file, required arguments for generic functions. Wait, what? Oh. Okay, I guess I will just go into actions and comment this specialization just in case. And also I want to remove the cache here. Yeah. Okay, let's restart just in case, and try and quick load that again. Okay, it is loaded. This is interesting. Oh, no! Yeah, god damn it. I misclicked and reloaded my Lisp image. God damn it. Alright. So I want in, not restart. Okay. What would happen if I call the demo? I mean, would that still work? I wonder. No, it still works, but I think... Oh, it is kinda slow. What the heck? I mean, it's awfully slow. It manages to, well, to perform very badly. I mean, how does that even... With 10 FPS? Whoa, that's some interesting stuff going on here. Let's have a look again at disassembly of make move action, for instance. So we should call initialize action at some point. Yeah, initialize action. Here we go. Now let's have a look at what initialize action is. Oh, and this is still... Oh yeah, what did I expect? It is still the stub for runtime dispatch. Okay, so this does not work very well, I guess. Weird, that's weird. So does this library do... Okay, so this, by the definition of it, sounds like it also makes the inlining. And again, I don't want the full inlining, I just want to omit the runtime dispatch. So well, dispatch supported. Yeah, equal is supported, that's good. Even if variable is bound to which was not left as a type declaration. Alright. I suppose I supported fully macro differences. Stepping dispatch is the custom meta class. The generic function call form is directly replaced with the body of the most specific applicable method. Again, this does full inlining. Heck. Okay, so what does this last one do? I'm not even sure it's from the same area. Specialization store system provides a new kind of function called a store function, whose behavior is determined by the objects, by the types of objects given as arguments to the store function. So I guess that's not entirely close, is it? So where's the full documentation? Problems were designed to address. Consider the function and solve for the most proximal operator. Arguments are alpha and lambda, blah 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 blah. To improve the performance of the function we solve, we turn to inlining. Fortunately, Green Performance has introduced a number of other problems. We have closed the generic interface to resolve, and the user must select the most appropriate solution manually. Okay, is there any more articles? Oh, there's the full tutorial here. Motivating. Oh, yeah, I'm reading that. The structure and relevant specifications. Yeah, that looks like the whole new set of macros and stuff, just orthogonal to close. That's not really I can use for my use case. Okay. So, well, actually I could have just replaced this thing, this generic, with just a single function, and well, just have the magic name of the function. So for instance, if I define the function named initialize move action, and then I would here in macro I would construct the name of that magic name of that function and call it here instead of generic. But it all looks kind of flaky. I mean, those magic names, well, I'm not coding in Python, so well, I want to use close here, but I don't want to resort to runtime dispatch. Why does that work so slow, I wonder? So this compiled. Well, my guess would be that this thing is not working, and I mean this equal specialization is not working too. Okay, so let me just have a look here. Maybe at issues. I'm used with closed classes. I guess it could. Okay, let's just read that. I'm very sorry for white background which flashes. I've read somewhere that Chrome cannot actually make the black background right from the start. So, well, yeah. This close signal segmentation, is there a meta class needed? There's no with built-in types. Oh yes, I happen to allow specialization on custom classes, but never found time to finish it. Ooh. And this was this year. But your issue has given you the necessary boost in motivation after most recent commit. Oh, the following should work. Okay. I'm not even specializing in some custom classes, I'm just specializing on the constants by equal. I mean, would that even work? Let's have a look at closed issues here. Here I'm Lambda, interested in improvement function. What was that? Based method is the right choice because we coexist with that method. One thing is still unclear is that having some receive the minus subtyped. I already wrote a paper on implementation details and submitted to ELS. Wow. And this was this year. There I also explained the differences to blah blah blah. The paper should be available soon. So you job. Now just take an example. If we run nothing body, line a call to the generic function applicable method. Alright. I bet it should soon appear on the EOS homepage. Let's have a quick look. My eyes. Okay. Right, so my dark theme is working very badly. Okay. So what was the Yeah. So where is the program? They're just slides. Scalable net objects. I should also look for that. Okay, maybe. Object functions. Right. Oh, for example, the main designators, and there is equal. Wait a sec, I should have it in a different. Yeah, different order. I thought so. Okay, so let's try. Alright, what is not a specializer or a type designator that can be converted to specializer? Okay, is this the wrong example? Check. Oh yeah, wait a sec, it was right the first time. Equal and then value, right? Equal and then value, alright. So it was right, okay. Everything just works. Yeah, except for me it doesn't. Hello objects. Organization. Computer program methods. The effective method. Organizations. And benchmarks. A drop-in replacement, huh? Alright, so why this drop-in replacement is even making my code run slower? And wait a second. Okay, what if I just move this one here? Okay, then remove the cache again and start my LISP. Maybe this will do the trick. Oh, what? The value nil is not of type index. What? I mean, like, during macro expansion of left expander initialization, value nil. Super weird. Well, first of all, am I really calling this somewhere except the macro? So I have different specializations. I have this one. I have this still the main call. Now this. Oh, alright, but this should work with fast generic functions library, and this should too. Now specialized for item pickup, for swing, the generic that method, and then just the call. I mean, this. Well, first of all, this should work, and the second, I don't really need the T specification here. I think type A. Yeah, I think I have it just in case. Oh, wait a sec. I have it for a reason where there are no initializer defined, right? Yeah, right. Right now I do have them defined for every action, so I can at least temporarily command that. This still should work. So let me try and quick load again. Oh, yeah, sorry. Oh, wait a sec, there are some messages about compilation, I guess that's why it was so slow. Oh, wait a sec, what is happening here? Alien from call 802. Whoa. Okay, let me just move back for a second. So let me command that one. Yeah, and remove that call. And then just cleanly recompile everything. Okay, so I maybe want to restart everything again. And recompile the stuff. Because what I've just seen is super weird. It was like compiling a ton every call of it. I mean, what? Okay. So there are some compilation messages from DSL for graphical user interface. That's to be expected. And then, okay, what the heck is that? No, that was just once, right? Yeah, those happened just once, but anyway, what was that? So yeah, everything is still fast, 60 FPS. Yep. Okay, so what is that? Doing sample pointer version to return value. Optimize, search definitions, type, function type, function, alien from call. That's really weird. Alien from call, huh? Okay, let's just do it step by step. Let's try and enable this, this fast generic function stuff on this generic and do nothing more. So yeah, of course it needs full restart. Let me just clear cache again. Oops, no. Alright. So I've just added this generic function class to initialize action, nothing more. So let's switch to package and try it now. Okay, this thing is happening again, I think. So it tries to compile some function calls to alien functions, I mean the ones that are defined outside Lisp, like in C, and it compiles it on the fly. No, those should be related to the compilation of DSLs for the UI, I think. And now, what? I mean, are you serious? What is this even? I mean, don't be ridiculous. How does that? Whoa. That's like super weird. So there is some alien func call with with 2 arguments. What could that be? And I guess there was some. Okay, can tell function type at compile time. Alright, I think I can find the actual place by this trace. So block with coordinate, then with sprite, with move action, multiple value call, a10. Alright. A10. So where do I have this a10 call? Oh, okay. Alright, so there are 2 places. At face target and here, closest walkable point. So my guess is the face target is culprit. Then a sec. With coordinate, then with sprite, then with move action. Wait a sec. Oh, wait a second. I'm still not quite sure I'm following, but I think the problem might be that this this method is being compiled every time. Yeah, now I guess I see what the problem is. The problem, at least it very well should be. The problem is that this method is compiled every time when I set this meta class from class generic functions to it. So it is being compiled like every time. At least that's my guess. With move action. Okay, where do I have move action? Oh, right, in def executor here. And then multiple call. Yeah, that's the one. With coordinate, then with. No, wait a sec. There is no with sprite call here. That all is very weird. Perhaps I should try that with different compiler. So let me try with Clojure, for instance. Oops, how do I? Yeah, with CCL. Come on, fork. Okay, so is this CL? Yeah, it is. So yeah, I want to keep load. I want to go and keep. No, I guess it would load everything. Because yeah, I haven't been using CCL in quite a while. But yeah, that's my secondary compiler for the whole game. I mean, the whole game compiles with Clojure CL, but it works a tiny bit slower. So, I mean, the CPU load is like percents more. So, oh, hello, required argument, lambda. I beg your pardon. Okay, can I just remove the cache but for CCL, like everything for like really everything. Oops, yeah. Okay, that's some evil thing to do, but yeah. Then let's restart it just in case. Yeah, it starts up quite slowly. Yeah, because I've removed all the cache. Yeah, that makes sense. Okay, and then let's try and quick load that. That would be fun if I just removed all of the cache and then it would fall with the same error. I reckon I've seen something like that in Bug Tracker just 5 minutes ago. Yeah. Okay, I think there was something in the issues here. So, yeah, right. Here with Lambda. That's what the one. Just creating a new project, here required argument, it seems to come from past method. If the project can be use CL, so I have to put other packages about filtering function and change using code. The can reproduce one more rules, blah blah blah. Then 205, copy the code from readme. Here it is, I created a project, okay. I can find that there's a problem. 9th of June. This is not actually a fetching function problem, but rather a problem with the way how SBCL loads generic functions and methods. If you move... Yeah, well, that's weird, but that's actually understandable if you know that Clojure CL and SBCL close implementation is kind of the same. I mean, it evolved from the same code base historically at some point. Okay, so if you move the generic function definitions into a separate file and load that first, everything works. Well, not everything. There's also some bugs that I have already fixed recently, but they're where the fixes are not yet in place. So the fix your problem. Place the generic and def method forms in separate files. I think I already done that. And also ensure that the call to seal domain is loaded before the first call to that generic function, or there won't be any implementation. Check out the list version and sealable methodologies. Meanwhile, I'll transfer to the readme. Try to detect the case you brought up in message. Alright, so first of all, which function of that thing I do have? LISP. So where it stores its projects, I mean the installed libraries, I always tend to forget this. Not them. Nope. Okay, what is here's the date, 2020 06/10. So that's like June, 10th June. 10th. This was on 9th. Okay, so I guess it made into the quick LISP. I think. Let's have a look. What could be made? 10th of June, yeah. So this should be in quick LISP, right? Yes. Now let me have a look at commits. No. The patch for readme, fixing typo, don't overwrite, PDCL done, skip bugs. No, this all should be in quick LISP. Right. Okay, so I think I will just make report this stuff here, and well, oh, that's Andrew, by the way, yeah. My mate, Andrew. So, right now, I guess I will just try that, and try and load that in both SBCL and, well, CCL. So first of all, in SBCL, oh, okay, so would it print something? No, I guess it should just compile. Alright, field overload, oh, okay. Impact, yeah, okay. Okay, I guess I should quick load that right here first. Okay, so I guess that compiled, right? I mean, I haven't seen any errors, so let me just try and call that. Yeah, it works. So let's try with CCL. Okay, it would take. Yeah, right. Right. So that's this error. Okay, I think I should report that this guy says this closed. Yeah, okay. Okay, I guess I will just do it later, or do I right now? Okay, I will just report it right now. So what's the version? Yeah, 1.11.5. So maybe I should provide backtrace. So how do I do that in CCL? I guess it's just that. Nope. Okay, let's just look at help. Let's just start function forms at local F. No, that's the backtrace frame. Oh yeah, B. So right. So just do it again to have a full copy. Oops. How do I do that? Spot view. Okay, maybe I want some nice thing here. Oh, what? Okay. Oh, and by the way, was CCL compatibility even defined here? Nope. Okay. Let's try to get private, blah blah blah, and not have flow, does it research? Yep. Alright. So it leaves me with two different alternatives which I don't like. I mean, I don't like both of them. Because, well, they both do some extra stuff, namely they do actual function inlining. I don't really want to do that. But I guess I will have to resort to that. Okay, so let me switch back to SBCL for a moment. Well, I think I just have to have a look at that seal domain stuff and try and figure out. Yeah, it has ccl.lisp file, so it does, I guess. I mean, it should support ccl. Okay. So seal domain. Where would be that one? Okay, maybe let's just clone that locally. Oops. Yeah, here it is, default. The name. Oh. List. Okay. Set F compiler method function, generic function name. I'm not even following. So, I mean that's the after method, right? And where's the weird. And what's here in this UL file? Oh, oops. Statical signature. Compute statical signatures. Alright. what's that? Compute static call signatures. Call signatures. Oh, that's from sealable met objects. Okay. Let's have a look at that. Generic method. Domain. Domain intersection P. Okay. Apply specializers. Okay, maybe that's kinda too hard to try and fix right now. Right, so I guess I would have to try these two other ones and, well, try and pick something. Okay, so I guess that's all for today. So yeah, I hope the author of fast generic functions will get back to me and will shed some light on this CCL situation. Okay, so I guess I hope I will make some progress in the week till next Saturday. So yeah, thanks again for watching. Get back next Saturday if you want to see more. And yeah, take care and goodbye.